So after discussing about the different type of graphs, let's talk about the nodes. Now node is a region or the place where the probability of the finding out of the electron is 0. Now there are two types of nodes. One is the radial node and another is the angular node. Now first of all, we will discuss about radial nodes. Now radial node is a spherical surface where the probability of the finding out of the electron is 0, and we get these type of nodes when we go far away from nucleus. If we want to find out the number of radial nodes, we can apply the formula n minus L minus 1, where n is the principal quantum number and L is the azimuthal quantum number. Now first of all, I want to explain you what actually node is. So we have already studied that this is 1s and this is 2s. So we know that 1s will be present in K shell and 2s will be present in L shell, and there will be a gap between first shell and second shell, and first shell and second shell, between these two shells there will be a vacant space, there will be a gap where there is no probability of finding out of the electron. So when we will move from nucleus, then from K shell to L shell to M shell, and M to N shell, we will find some gaps, as we discussed in the Bohr model also, that energy is quantized. So there will be shells like K, L, M, N, and there will be gaps between K, L, M, N. Those gaps are called nodes, and as we are not changing any angle, we are moving from nucleus and going from K to L, L to M, M to N. We will call them radial nodes. So we are changing the radius. Radius of K will be different from the radius of L, and that will be different from the radius of M. So there will be gap in between the first shell, the second shell, and the third shell. Those gaps are called radial nodes. Let's solve one question based on that. Now this is the question, and he is asking how many radial nodes are present in 4p subshell. Let's discuss it. Now the solution, the subshell is 4p, right, where n is equal to 4, this is the principal quantum number, and L, which is azimuthal quantum number, for p we know that it is equal to 1. So the number of radial nodes, which are also called spherical nodes, that is equal to, we can find out by the formula n minus L minus 1, right? So what is the value of n? That is equal to 4 minus 1 minus 1, and it is equal to 2. So there will be 2 radial nodes. So, but one more thing comes here. Where are those nodes? Let's discuss that also. Now we know that the shells are, if we talk about the shells, they will be K, L, M, and N, right? Now in K shell, there is no p orbital is present. In L shell there is 2p, there is 3p in M shell, and 4p in N shell. So definitely we know that between L and M there will be an energy gap, and between m and n, there will be energy gap. So there will be a place between n and m where the probability of the finding out of the electron will be equal to 0. So between 2p and 3p there will be a node, and between 3p and 4p, so that's how there will be 2 radial nodes for 4p. That was the final answer. Now let's discuss about angular nodes. Angular nodes are those nodes which we get when we change the angle without changing the distance from the nucleus. I'll tell you the meaning. And angular nodes are also the planes which pass through the nucleus without touching the electrons or the electron cloud, right? First, we should know that what is the formula to find out the angular nodes, and the formula is the number of angular nodes is equal to the azimuthal quantum number, that is equal to L. So the number of angular nodes is equal to L. The number of radial nodes was n minus L minus 1. So the total number of nodes for a particular subshell will be equal to n minus 1, right? So let us see that what is the actual meaning of angular node. Now this is S, this is P, the shapes we all know. Now we have a plane and we have to cut this S subshell in such a way that if we pass that plane through the nucleus, then electron cloud should not come in between. Can we cut? If we cut it like this, then electron cloud will definitely come in between. Here also, because it is spherically symmetrical, we cannot find any plane passing through the nucleus which does not touch the electron cloud. Hence, the angular nodes for S will be equal to 0. Now if we talk about P, this is the area, or this is the region where the probability of the finding out of the electron is there. This region and this region. But if we change the angle, like this, if we move from the upper lobe to the lower lobe, and if we go from here to here, then definitely we will get one region here. So this is the region where the probability of the finding out of the electron is 0. And if we talk about the nodal planes, this is py orbital. The electron cloud is along y-axis. Therefore, zx will be the nodal plane. So how many nodal planes are there? One nodal plane. Therefore, the number of angular nodes will be equal to 1, right? So this was the meaning of angular node. Let's solve a question. Now, in this question he is asking which d orbital does not have any nodal plane. Now, is it possible? Let's see. Now, this solution is, there is an exception, and the exception is this one, dz square. Now, we all know that in case of D, if we find out the number of angular nodes, the value of L is equal to 2. But in the case of dz square, if we want to cut it, or if we want to pass one plane from the nucleus, it is not possible that the plane should not touch the electron cloud. So if we go from anywhere, there is no plane possible which will not cut the electron cloud. So this was the meaning of angular nodes and the radial nodes. Let's discuss the electronic configuration.